Hey all, welcome to Azure Community Conference. I hope you are all having a great day attending this conference. There's a lot of talks, interesting talks. I hope you are having an amazing day and enjoying. The same lineup, I'm happy to share that I'm going to talk about interpretable machine learning with Python examples. And my name is Abdul Majed Raja, and this is my Twitter handle, One Little Coder. A little bit about myself. I run and organize Bangalore R user group, of course, before pandemic, but right now we are not doing great, but I hope the world becomes a better place so that we can all meet again, like how the world used to be normal. I also do a lot of open source contribution, not probably a lot, but some. You can find my hobby projects on github.com/AMRRRS. And I also like to write a lot of articles on Medium. And finally, recently I'm trying to make videos on YouTube. So you can find my videos at One Little Coder, and I would really appreciate if you check it out and let me know your thoughts. So what is this talk going to be about? This is how this talk is structured. So initial half of this talk is not going to have anything related to machine learning, and later on we are going to increase the level of machine learning that are required to understand this talk. This talk is going to tell you about interpretable machine learning, which is also known as explainable AI. Why is this interpretable machine learning required? How is it even relevant to me? And the types of interpretability, what like global, local. And then finally, we are going to look at interpretable machine learning with Python references. Specifically, we are going to talk about two different methods called LIME and SHAP. That is where you need to have ML understanding, but until that you probably don't need even any ML. But I would also like to emphasize that even if you do not have any machine learning skill or technique, or you're not part of machine learning, still I think this talk will be relevant for you. That is what we're going to understand in the third section, which is how is it when relevant to me. So if you have any questions, please let us know in the comments, or after the talk you can get in touch with me and you can get to know the answer. So this talk is heavily borrowed from this book called Interpretable Machine Learning, which is a very great book, made it open source, like free, sorry, made it free by Christopher Molnar. So thanks so much, Christoph Molnar, for making it completely free for us. And I hope you, after this talk, after listening to this talk, if you're interested in the subject still, you should definitely go and check it out. This book, this is an amazing book, and it is so kind of the author to make it completely free and available to everyone on the internet. So, of course, every talk begins with a joke. So, let's make a joke. So, what is this joke? So, person A asks person B, who is probably, let's say, a data scientist or machine learning engineer, "Oh, this is your machine learning system. And what does it do?" So, person B says, yeah, you actually pour a lot of data into this big pile of linear algebra, and then that collects the answers on the other side of it. So, it's like a funnel. You pour data, and then you have linear algebra, and then it collects the answer on the other side. And person A asks, "What if the answer is wrong?" So person B says, "Oh no, simple. You just stir the pile and start looking for more answers," which is kind of an insider joke within data science community. That a lot of data scientists, sometimes what they do is, if they don't get the right answer of what they were initially looking for, they start for more answers, because ultimately they want to show something, right? Everyone tries to impress their boss, and then everyone wants to show something. So even if you don't have what you're looking for, you still try to show something, and that is how some people do it, which is not entirely right, and that is what this joke is about. Now let's move on to the serious subject. So what is interpretable machine learning or explainable AI? Interpretable machine learning refers to the methods or models that make a particular machine learning system's prediction or behavior understandable to human beings. So if you have built a model, or machine learning model, or artificial intelligence model, a statistical model, whatever you would like to call it, if that model, you understand what is the prediction and how is that prediction made, like what is based on what that prediction is made. So if you have understanding about that particular thing, then that is called interpretable machine learning. So you have a machine learning system, and you have the ability to interpret or explain how that machine learning algorithm or model is making prediction, and that is what we are calling as interpretable machine learning. And then the buzzword for us, explainable AI, also known as XAI. So that is what IML is all about. Why IML is required? You might ask, right? Okay, we have got machine learning, but why is even IML required? So before even we move on to IML, so let me give you a very brief overview about why are we in this situation that interpretable machine learning. You're talking about interpretable machine learning. Why is even not machine learning interpretable? That's the first question, right? If you separately need something called interpretable machine learning, why machine learning is not interpretable? So basically, if you want to visualize a plot, a graph, as the complexity of the machine learning models that we build, the algorithms that we build, the explainability or the interpretability of the algorithms decreases. So it has a negative correlation with the interpretability and accuracy or complexity of the algorithm has a negative correlation. So if you want more accuracy, then you want more complicated model, but more the complicated model is, lesser the interpretability of the model. And that is why we have the necessity of having a separate stream called interpretable machine learning. So now, why interpretable machine learning is required? First, most important thing is fairness. So you want people to believe that the model or technology that you have built in is unbiased. So you want people to know that you have built a solution, or you yourself want to know that you have built a fair solution. You have built a fair machine learning model that is completely unbiased. It's not going to discriminate people based on their race, gender, religion, country. So it's not going to do any of those things because you have built an unbiased model, and that fairness is only possible, that fairness is ensured only if you understand what is happening behind that prediction. Second thing, privacy. So a lot of data scientists usually get very excited, happy about any data that they can get, but the truth is sometimes we need to draw a line and say that okay, data beyond this is not ethical, data beyond this is going to violate somebody's privacy, and I'm not going to touch the data. And that is what we call as sensitive data. So if you want to ensure that sensitive data is not used, no privacy is violated in the machine learning algorithm that you have built, then you need interpretable machine learning to understand how this machine learning prediction is happening. The next thing is reliability. So any solution that you build has to be reliable by your stakeholders, otherwise your solution is not going to be trustworthy. So reliability and trustworthiness are two most important things, so that when you build something, you are actually part of your data science team or a machine learning team is actually part of a very small organization, right? There is a huge organization, and within that there are a lot of business functions, and within that there is a small team that is going to make this prediction. And if you want to fit very well within this entire ecosystem, you need to ensure that people trust you, you need to ensure that people trust or rely on your model. So for you to ensure that, you need to have interpretable machine learning. The next thing is establishing a causal relationship. So if you have made a prediction, let's say there is a credit called credit card default model prediction. So if you have made a prediction, now your business is going to ask you, okay, on what do you think are driving factors that drive whether a particular person is going to default or not default. So that information is something that you would get only if you have causality established, and for that you need to have interpretable machine learning. And then the next thing is that we just discussed, which is trust. And then finally, if a company doesn't care about any of these things, there is one thing that they would definitely care about, which is legality. And legality is nothing but whether the model that you have built can be explained, because based on GDPR, which is widely implemented across Europe, there is a clause called right to explanation, right? So if I have applied for a loan, let's say I'm in Europe, and then I have applied for a loan and my loan has been rejected, so I have every right to ask why my loan has been rejected. So this question, when it is being asked by a customer, a company cannot simply say that, oh no, sorry, we don't have that information, because ultimately an algorithm made the decision, we cannot explain it. So they cannot simply say that, because according to GDPR, you have to have an explanation, and everyone who is involved in that has that right to get explanation. So for legal reasons, sometimes you need to have interpretable machine learning. And to be honest, this is one thing that a lot of companies care more about any of the above mentioned reasons. So simply saying, an interpretable model, when we say an interpretable machine learning model, is something that can tell you, that can explain you why a particular decision has been made, whether a loan has been rejected, or whether somebody's visa has been rejected, whether somebody's job offer has been rejected, why a particular decision has been made, so that a human being can intervene and then judge whether the machine learning model is actually learning and then making the decision, or it has some inherent bias that we don't want that machine learning model to have. So that can be done only if you have interpretability within the machine learning model. Okay, let's we saw a lot of reasons, but let's look at a reason. Let's look at an example. What happens if something goes wrong? Like, what really happens? And the example is from one of the most trusted brand in the world, which is Apple. Okay, this person is called DHH, and he is very well known in the developer community, technology community. He is the creator of Ruby on Rails that powers almost like millions of web applications on the internet. So what has happened is DHH and DHH wife, both of them have Apple cards. So probably like few years back, Apple launched a card called Apple Card, which is a credit card that Apple launched in tie-up with Goldman Sachs. So both DHH and DHH's wife have Apple Card, and both of them are working, both of them are making their money, both of them handle their own account. And when DHH's wife, they what they found out is just DHH's wife has less credit limit than DHH, which means DHH can get more loan, more spend more using Apple Card than his wife, which he thinks is unfair and which is right. And when they try to reach Apple to get the result, to to hear from Apple customer care what is happening, why is the credit limit for two person who makes same amount of money, almost, and does similar tax returns, live in the same place, and why their credit limit is different. But the problem is now Apple customer care says that it is the algorithm that has made this decision, and we don't know how that algorithm has made the decision. And that has really made DHH angry. And then he has made this tweet, and this tweet has gone hugely viral, and even it got support from Apple co-founder Steve Wozniak, and a lot of people jumped in to say that now, one, it has to be Apple has to ensure that their algorithm is unbiased, and then the way they can ensure that their algorithm is unbiased, that they are not biased against women entrepreneurs or women, working women, or in fact women for that matter, is by explaining how a particular prediction is made, how a particular credit limit is set. And this is a classical example of how, if you do not have interpretable machine learning, a brand as big as Apple can have its brand value tarnished. It was a huge PR issue for Apple. A lot of news articles were written about it, and then a lot of people spoke against this bias, inherent bias within this credit limit that Apple and Goldman Sachs has implemented. And this is one such example where you don't want your brand to have this impact, right? Like, let's say you are a CEO, or you are somebody who works in such a company. You don't want to see that this kind of news happening about your company, where a huge technologist who's very well respected in this domain speaks against your program. So it's very important. Interpretable machine learning is very important for you to establish trust in the society, and then make sure that everyone believes or everyone knows how a particular algorithm decision is made. Let us move on. Now you might wonder, like, how is it even relevant to me? If you are a CEO, maybe I'm going to care about brand value, but how is it relevant to me? First, I'm going to talk about three different roles. One is a data scientist, the other one is a technologist who is like part of our technology team, and then the other one is like no one, nothing, normal human being. Okay. So first of all, if you are a data scientist, everyone likes to take pride in their work. I could be a carpenter, I love what I make. I could be a tailor, I love what I make. I could be a baker, I love what I make. The same way, if I am a data scientist, I just love what I make because that's my work that fulfills me. But what is the point of taking pride in your work if you have no clue about what is your work, how a particular prediction is made? You cannot simply say that the algorithm made the decision, right? So what is your role? So there is an insider joke within data science community that a lot of people actually say there are some kinds of data scientists who just all they do is import scikit-learn. That's what they do. Scikit-learn is a very popular machine learning framework, and a lot of people what simply do is they just import scikit-learn. It's an insider joke. It just simply says that you simply blindly follow something without understanding what is happening. So if you are a data scientist who would like to take pride in your work that you do, you need to have understanding about why a particular prediction is made, and that is why interpretable machine learning is very relevant to you. Okay, let's say I'm not a data scientist. I'm not a machine learning engineer, but maybe I'm a technologist. I'm just a team member who is part of a big organization. How is it even relevant to me? Very simple. If your team or your broader team business function produces something, and that is going to be deployed across your organization or for all your customers, then if something goes wrong in that, it's not just the data scientist who built that, it's not just the data science team, it is the entire team, the broader team, extended team is going to get impacted, and everyone is going to ask question, and your team's reliability, your team's trustworthiness is going to be put at stake. So if you don't want to do that, then whenever there is a model built by your data science or machine learning team, you need to pay attention to understand how a particular prediction is made, whether the data science team is capable enough to explain or interpret what the prediction is about. And that is why interpretable machine learning is quite relevant to you. Oh, maybe let's say you're not a data scientist, you're not even a technologist, you're just a normal human being, you're just a common man, you're a normal human being. And how is it relevant to you? And this is the most important reason why you should care about machine learning, interpretable machine learning. There are machine learning systems coming into a social system, social machine, everywhere you would see these days there is a machine learning system. Whether you want to get a loan, there is a machine learning system. Whether you want to get a passport or a visa, there could be a machine learning system. There are anti-criminal CCTV monitoring systems there. So if you are part of a social system and there is a machine learning model in the social system, like HR department, there's a machine learning model that is going to decide whether you can get a job or not. So if you are part of a social system and there is a machine learning model, then the data point is you or I or somebody you care about, like how it happened in DHS case. It is somebody he cares about, and that person is being there is a model that is biased against that person. So now it is your responsibility and my responsibility to ensure that the machine learning model that is deployed in the social system is not biased against either you or me or somebody we care about or some marginalized group of the society, so that they don't become further marginalized. So that it is our responsibility to ensure that the machine learning model that has been deployed is fair, it is unbiased, it is ethical, and it is not going to discriminate any marginalized group. And that is why interpretable machine learning is most important, most relevant to all of us on this planet, because machine learning systems are going to penetrate into every social system, and we need to ensure that it is unbiased. And the only way we can ensure that is by having interpretable machine learning in place. I hope I've convinced you that interpretable machine learning is relevant to you. And if you are convinced, and now we are going to see how it is and what it is. First of all, interpretable machine learning can be categorized into two broad categories. One is to say that, okay, it can be either model specific or model agnostic. The other set of categories, it can be either global interpretability or local interpretability. So let's look at model specific. So there could be a method that could help you explain a particular model that is model specific. So now let's take linear regression. The coefficients of a linear regression is going to help you explain a linear regression model. In fact, for that matter, you can now take that linear regression model's coefficient, put it in Microsoft Excel, and then you can just add a formula, and then you would get the same prediction output. So this is an example for a model specific interpretability. So this explanation, that coefficient that you took, or this methodology that you followed, is only applicable for that particular model, and now you cannot take a random forest and explain it like that. So that is where model agnostic methods come into picture. Model agnostic interpretable machine learning methods help you explain models irrespective of what model it is. So it could be an XGBoost model, it could be a light GBM model, it could be a cat boost model, or it could be a random forest model. Still, you can use this particular method and then you can explain it. So the method that we are going to look at today is model agnostic. Next category is global interpretability and local interpretability. What is global interpretability? When you have a machine learning model in place, global interpretability means you, at a overall level, at a higher level, at a global level, you have some understanding about what are the features that are driving this model prediction, this prediction. So for example, variable importance plot or a partial dependency plot are examples of global interpretability. So these things explain you why, in which direction this entire machine learning prediction might exist. So for example, Let's take a credit called default as an example. So you can have a machine learning model at a global interpretability level. Your model can the interpretable machine learning method can tell you that, okay, if somebody doesn't receive salary for the last 3 months, then they are high then they have a high chance, high likelihood of defaulting. And this is something that you would get to know from your variable importance plot. Maybe there is a feature called last 3 months salary, and then when that is less, then there is a high chance of that person defaulting. This is at a global level. And what is local interpretability? Local interpretability is where you take one particular data point, you take one particular case, and then you have a method that can explain why particular prediction has been made for that particular point. And that is called local interpretability. And we talked about the legality, right to explanation of GDPR, and local interpretability is very important for that. And then the methods that we look at today will help you in local interpretability and also model agnostic. So let's quickly get into the first method that we're going to look at. The first method is local interpretable model agnostic explanation, which is called LIME. And LIME, what LIME does is, as the name suggests, it is interpretable and also it is model agnostic. And what LIME does is, you can see that when there is a global model, which is a black box model that you cannot understand, it is an opaque model. What LIME does is, it actually builds a surrogate model. So let's say this is a model that differentiates between blue and red, and now you have a global model, you have a decision boundary that's quite nice. And now what LIME does is, if you want explanation for this particular data point, LIME will make a surrogate model. LIME will make a model that can be interpretable for this particular set of data points, and then it will try to make this model as an approximation for the entire black box model. And that's what LIME does. For example, entirely you have a random forest. LIME will now try to make a linear regression, logistic regression here, and then it will try to make some prediction. So this is a very vague example to say that it will build a simple model as a local approximation of the entire global model that you have built by from a sample set of data, and then it will try to explain it why that particular prediction is made. And it will build that local prediction, local model, fit that local model in such a way that it is aligned with the global prediction. That is how it is made. I hope it makes clear. Otherwise, you can ask more question or you can research online. LIME works very well for tabular data, text data, image data set, computer vision data. So it works for different types of data. So let's have a quick look at LIME demo. So first, LIME can be very simply installed using pip. So pip3 install LIME will get you LIME installed. In my case, I have Python 3, so I'm saying pip3. But if you're using Windows and you have Python 3, you can just simply say pip. And LIME data package can be loaded like this, LIME. And we are going to deal with only tabular data, so I'm just loading LIME tabular. And then I'm going to use a random forest, so I'm loading random forest here. So this is a very popular data set. Almost everyone who has ever done any problem on Kaggle or ever come across any data science problem would probably know this Titanic data set. Titanic data set has one column that says survive, which is to say that whether a particular person has survived or not survived based on a lot of other columns like name, what is the class that they travel, what is their gender, what is their age, what is their ticket fare. Based on all these information, the final there is a column that says survived or not survived, and we are trying to build a model that will learn this attribute and then predict whether somebody will survive or not survive. Simply, we are going to do a lot of data pre-processing. For example, we are dropping features that are not required, like unique features. We are going to create dummy variables. We are going to fill missing values, and then finally we have a training and test data set. And then once again we build a random forest classifier, and that classifier gives us 80% accuracy, which is not so great for a Titanic data set, because if you go on Kaggle you would even find 98% accuracy. But let's just for the sake of demo, I think 80% accuracy is good enough for us to move further. Now the model is ready. As a responsible data scientist, as an ethical data scientist, your next duty is to build a model explainer, and that's what we're going to do. The first step to build a model explainer using LIME is you need a prediction function. So predict proba will give you the predicted probability, and then you're converting into float, and then you are saving that function. And then you are taking the training values and putting it in X. So now you are creating a tabular explainer. So LIME tabular explainer you are creating. And in this case, in our case, we are actually giving everything as a numeric variable, because we have created dummy variables, we are giving everything as numeric variable. But if you want to do this in the right way, you have to separate numeric and categorical variables. You have to pass on categorical variables separately, which I'm not doing it here because it's a simple demo. But if you want to do that, you have to do it that way. So you have separate categorical variables, separate categorical value data. So in our case, it's we are treating everything as numeric variable, and the class name is not survive. So this is how test data looks like. Once the explainer is built, now we need to pick one particular data point, and then we need to say that okay, how this particular prediction is going to be explained. So let's take 310, value 310. So if you see 310 is survived, is the actual value. So let's see how the prediction is going to look like. 310. So now you take the chosen instance. In our case, 310 index is the chosen instance, and you pass on that chosen instance with the function that we created. And you want to also say how many number of features that you want Lime to pick up while making this prediction. So in our case, we have sent 10 features. We actually do not have a lot of features. So you can just simply say anything, 10 features or anything. But if you want to reduce it, you can further reduce it. So you can see that it is saying, let's run it. It is saying that the person would definitely survive, like 100% it would survive. And it is saying the reason I'm making this prediction, like survive is orange, not survive is blue. So it's saying the reason I make this prediction is for because of these reasons. Male gender is 0, which means they're not male. Female gender is 1, which means they are female. And this is their ticket fare. And you can even in fact see that because their ticket fare is greater than 31, it is trying to say that this person would survive, and a lot of other reasons. And it has a very very less value for not survive because of the following two reasons. But you can understand that this is making this prediction. And even for somebody who is not from machine learning background, looking at this chart, you can easily make sense that okay, the prediction is it will survive, and the reason it is making this prediction is because this, they are female, their ticket fare is greater than 31, and so and so reason. Let's take a different data point and then try to understand. In this case, let's take somebody who will not survive, 57. 57 is, yeah, they will not survive, and these are the values. 57. So it says 80% chance that the person will not survive. The actual values, they will not survive, and it says 89, sorry, 79% that they will not survive. And then the reason it says that they will not survive is, first, that person is male, and then they traveled in third class, the passenger class is third, and also their ticket fare is very less, and also their age is around 30. So these are the reasons it says why that person will not survive, probably 80%. But it also has some doubt saying that this person might survive because they traveled in embarked in class C, and there are some other reasons. So basically it gives you a combination to understand why that person might survive and why they might not survive, and why is this prediction goes between 79% to 21%. And that is quite explainable, like you can easily understand from here. So basically the point is, if you have created explainer, after that you just have to pick an instance, and then you have to send the instance value with the prediction function and the number of features that you want. So if you want only 3 features, you can say that okay, based on only 3 features you have to explain. If you have like more number of features, you can. But the main thing is, the more number of features you keep on adding, it's going to be computationally expensive. And that is Lime. It is quite very very easy for you to understand. So like I said, if you have categorical features, you have to give categorical features separately. And what are the advantages of Lime? Lime is model agnostic, as we saw. It works with the different data types. It is really easy to interpret, even for somebody who is from non machine learning background, or even from non technical background. Lime is relatively faster than SHAP because SHAP is computationally expensive. And Lime also gives you one more important thing, which is called local fidelity measure. So at this point, you might ask me, how do I know the surrogate model that you build is actually a good model? And that is where local fidelity measure comes into picture, saying that, okay, the local model that I'm going to build, It this local fidelity measure is going to tell me how good quality this local model that I've built is, the surrogate model. So local fidelity measure is a nice measure to help you understand whether the local model that you built, the surrogate model that you built, is of good quality, it has high accuracy, so that you know that the local model is going to approximate well with the global black box model. it has a it has some advantages. First, Lime works based on a sample of data, right? It's going to pick a sample of data and then do the local model, because of which the sample might always differ, and then the interpretability value could also differ. So just now we saw 79% and 21%. Sometime it could be 80%, 20%, sometime it could be 85% and 15%. So the interpretability value could change, which could make it unstable. So whenever there is a change in figure, business might not like it. The local model approximation, if it is bad, so we just said that there is a value called local fidelity measure, and that will help us understand if the local model is a good model. If the local fidelity is bad, if it has a very bad accuracy, then you cannot rely the Lime model. So you can rely on Lime model, Lime interpretability, only if the local model has good accuracy. If it doesn't have, your Lime interpretability is really unreliable. And for a lot of beginners, the first time setup could be slightly tedious, because you have to create data set in a certain form, you have to have categorical values, you have to have the explainer build, you have to have the prediction function build. So it could be slightly tedious for first comers. It's not a big disadvantage, but it is, just to call out a disadvantage. Despite all the disadvantages, Lime is really popular. You should definitely check it out, because it's easy, less computational expensive than SHAP, and it's easy to like easy to understand. So now let's move on to SHAP. Before we see SHAP demo, let's understand what is SHAP. SHAP stands for Shapely Additive Explanation. And what does it mean? Shapely additive explanation uses Shapely values. Shapely values come from game theory. So Shapely values come out of a strong theoretical foundation from game theory. So what a Shapely value helps you do? So if you are part of a game, if you are, let's say you won something, three people have played, and all of the three have won something, but everyone has an individual contribution. Now Shapely value is to help you divide this payout for the individual players, and now replace these players with column names, features, and replace this payout with the prediction of an algorithm, machine learning algorithm. And that is where Shapely values now help you explain the machine learning prediction. So instead of the payout, you keep the machine learning prediction. So let's say that you went to a hotel, like three friends, and then you ate something, and now three of you are trying to divide the payment that you have to make, and that is where Shapely values helpful. Now instead of that um, payment that you have to make, let's say there is a machine learning prediction that says 93% survival. Now you have three columns. Now how you are going to separate that 93% for three columns, that is going to come from Shapely values, and that is what this Shapely additive explanation helps you identify. So if you want to know more about Shapely values, you can click this link, and then you can understand. Let's get into Shapely demo. So I am explaining this in my VS Code Jupyter environment, but you can have a look at it sorry, anywhere. So first you have this is going to be using XGBoost. So this is using a data set called US adult income data set. So this data set has a lot of attributes, and then finally it has a class value that would say whether that person is making more than 50,000 US dollars or less than 50,000 US dollars for a year. So now we are loading the data set, and as you can see, shape is also one pip away. So you can just pip install SHAP and import SHAP. And once you do that, now load the data set. Once you have the data set, split between train and test, and then because we are using XGBoost, we are building a train D matrix and test D matrix, and this is how your data set looks like. You can have a look at it. It has age, working class, education, marital status, occupation, relation, all these information. So now we are defining the parameters for our XGBoost. So based on these parameters, we are trying to train the XGBoost. Once again, because of the demo, I did early stopping in 10 rounds, but ideally you would do more. But because this is just a demo, I just wanted to quickly show it, so I'm just showing it here. So basically what we are trying to see is we are seeing approximately 72% accuracy here in this case. So once you have the model in place, shape is quite easy to get you started. Like unlike line, you don't have to create a prediction function, you don't have to do all those things, identify categorical values or all those things. All you have to do is take your model, because this is a tree based model. You have got something called a tree explainer. You pass on this model inside this, and then SHAP.tree explainer, you take this model, and then this explainer will now, you are going to extract shapely values from it, and that you are assigning it. And now you have to just pick a test instance for which you want to understand why the prediction has been made. So in this case, we are going to look at a particular value. Let's first look for 32560 is our index value for which we are going to look at. So you have tree explainer, you just build the model. Until this, it's a normal process. Then you have a tree explainer, and from that you have shapely values extracted, and then you're going to create a force plot. So what you have in the force plot, you're going to pass the shape explainer's expected value from the explainer, then you are going to pass the shapely value, then you are going to pass the values from x display, all these values. Now this force plot will explain you based on these attributes, this shapely values, what is the value made, and then how it is. So as you can see, this is the base value, and you can see everything that is red color, or I don't know what, like maybe like pink color, strong pink color, everything that is in this color is going to take the value above the base value. Everything that is blue, that is going to take the value below the base value. So it's going to take the prediction value above the base value, and blue color is going to take the prediction below the base value. And as you can see, it is basically trying to say that this prediction, this person is going to have more than 50,000 USD as salary, annual income, because of so and so reasons. As you can see, this is also interactive. So you can see the interactive visualization from this. That's what we loaded here. If you see SHAP.init.js, we just loaded the JavaScript here. So because of these so and so values, it is going to have higher value than the base value, which means the person is going to have more than 50,000 US dollars. And you can see also the real value is true. So the person is making more than 50,000. Let's look this for a different one. So this is a different value, and the actual value for this is false, which means that person is not going to make more than 50,000 US dollars. So let's change. This is for you to understand how the plot would change. If so, now you can see the base value is here, and you can see these values have taken the value away from the base value. So it has these values have tried to take the value higher than base values, but you can see there are a lot of factors that are bringing the value lower than the base prediction value, average prediction value for the data set, which means because of these reasons you are saying that the person is not going to make more than 50,000 US dollars, and that is primarily because of these values. While these values are trying to take the prediction above, these values have taken the prediction below, which means from the average base value, which means the person is not going to make more than 50,000 US dollars, and it is the same information you can see here. So false, which means not more than 50,000 US dollars. While SHAP is also like Lime in this case, helps you explain the local interpretability, local value. SHAP also does another good thing, which is it helps you aggregate every information, every local information, and it helps you give you a summary plot. The summary plot looks like this, which means it says for this particular problem, to predict whether that person has more than 50,000 USD or less than 50,000 USD as annual income, relationship is the most important variable, age is the next most important variable, education is the next most important variable, capital gain is the next most important variable. So it basically takes the average of SHAP values for individual variable features, and then it makes this plot. And this is quite handy because now with one package, one method, you can explain both local and also global, and this is quite handy. And then a lot of times when there is a conflict between Lime and SHAP, SHAP is usually considered to be more reliable because of its strong mathematical foundation, theoretical foundation, and you can actually see that in a lot of places. So that is SHAP. Like we just saw, you can have global explanation also. The same way you can have local explanation, you can also have global explanation. So some advantages of SHAP. It's quite easy to get it up and running. It has a very strong theoretical foundation in game theory, which makes SHAPE a nice candidate for legal and compliance requirements. Because if you do not have a strong foundation, unlike Lime, which has some unstable results, if you do not have strong theoretical foundation, it's very hard to defend your case with the legal department. But because SHAPE has a strong theoretical foundation, it's quite a good candidate for legal and compliance requirements. Tree explainer is really fast. The one that we used is tree explainer. You can see tree explainer. It's quite fast because for tree based models, if you have tree based models, which is like random forest XGBoost. And if you have SHAP, the good advantages, I think the biggest advantage is you have one unified package that can help you explain local, also global interpretability, unlike Lime, which is only for local interpretability. And SHAP gives you visualization, interactive visualization. You just saw, right? And everyone likes interactive visualization, so that is quite good. Like it's easy for business stakeholders to understand, play around with the data and understand because of its interactive visualization, which can be deployed on notebook, Jupyter notebook, or if you have a blog, you can publish it. There are some advantages. I think the biggest disadvantage, biggest con or disadvantage for SHAP is it's really computationally expensive. It means it's very slow. Kernel explainer is very slow, which is also model agnostic. It doesn't matter whether you have a linear model, whether you have a tabular data, whether you have any data. Kernel explainer is model agnostic, but it is really slow, and it also ignores feature dependencies, which means if one feature is dependent on another feature, it ignores that. Tree explainer addresses both, but it is only for tree based models. It's not like truly model agnostic, but it is very computationally expensive. There are some solutions recently available that helps you run Shapley explainer on GPUs, but not everyone has the luxury of running a GPU within their organization for a hobby project, or even for the purpose of making prediction explanation. But other than computational problem, Shapley is really good. Like we just said, if there is a conflict between Lime and Shape is usually considered to be the more reliable solution, and it is a really good solution for you to use, and it is quite easy, like really easy. 3 lines, you have interpretable machine learning in place. And with that, we have come to an end to the talk, and I hope you really enjoyed the talk. Thanks to the sponsors who made this conference possible, and also thanks to the community who spreaded word about this conference. And finally, thank you from me for listening to this talk, Interpretable Machine Learning with Python Examples. This is my Twitter handle, One Little Coder. You can follow me there. You can let me know your thoughts about whether this was a useful conversation that you had. You've heard about it before. Is your organization practicing interpretable machine learning? Or if you have any a question from this talk, you can definitely tweet at me and ask me the question. I'll be so happy to answer you. If I do not know the answer, I'll be at least happy to redirect you. Once again, thanks to the Azure Community Conference for having me here, and I hope you're going to have a great rest of the day. And they have a huge, good lineup of rest of the talk, and I hope you have a good time and you enjoyed this conference talk also. And please let me know on Twitter or in the chat how you enjoyed this talk. Thank you for listening, and see you some other time.